1987, the smallest automaker in America released a six-cylinder engine that made more power than a Ford 5-liter V8, from 4 liters. With 2 fewer cylinders, it weighed 483 pounds, 1 pound more than the engine it replaced. That engine would outlive the company that built it by nearly 20 years, and it would outlast most of the V8s that were supposed to be better. This is the story of the AMC 4-liter straight six, an engine designed by a company that couldn't afford to fail, backed by French money, controlled by French computers, and somehow, against every reasonable expectation, became one of the most reliable power plants ever bolted into an American vehicle. 300,000 miles without a rebuild was not exceptional for this engine. It was expected. It was routine. People who rebuilt them at 300,000 miles often found the bearings hadn't even worn through to the copper layer yet. The engine was still within spec. After 300,000 miles, that is not normal. To understand why the 4-liter matters, you have to understand what American Motors Corporation was dealing with in the mid-1980s. AMC was the perpetual underdog of American automaking, the little guy. Founded in 1954 from the merger of Nash Kelvinator and Hudson Motor Car Company, they had spent 3 decades doing more with less than anyone in Detroit thought possible. They gave the world the Gremlin, the Pacer, the AMX, the Eagle, which was the first production all-wheel drive passenger car in America, and they owned Jeep. That last part is the only reason anyone in the industry was still returning their calls. By the early 80s, AMC was surviving on life support from Renault, the French state-owned automaker. Renault had taken a controlling interest over the course of the late 70s and early 80s, eventually holding 46.1% of AMC's outstanding shares. The arrangement was supposed to be mutually beneficial. Renault would supply small car platforms and advanced technology. AMC would provide access to the American market, manufacturing infrastructure, and a dealer network. On paper, it made sense. In practice, it meant an American company, famous for building Jeeps and muscle cars, was now almost half owned by the French government. The cultural friction was significant. Renault executives in Paris saw AMC as a money pit. The AMC engineers in Kenosha, Wisconsin, saw Renault as a source of good technology wrapped in frustrating bureaucracy. Both were right. The Jeep lineup was the only thing generating real profit. Specifically, the new Cherokee XJ, which had debuted for the 1984 model year as something genuinely unprecedented. It was the first non-military four-wheel drive vehicle ever built with unibody construction, no separate frame underneath. The body was the structure. That decision saved approximately 1,200 pounds compared to conventional body-on-frame construction. The XJ was compact, lighter than anything in its class, and genuinely capable off-road in a way that shocked even the engineers who designed it. 3 separate off-road magazines named it 4x4 of the year simultaneously when it launched. That had never happened before. An unprecedented triple crown that told the industry something new had arrived. The man who oversaw the XJ's engineering was Roy Lunn, Vice President of Engineering at AMC. If that name rings a bell, it should. Before AMC, Lunn worked at Ford, where he helped design the GT40, the car that beat Ferrari at Le Mans. Born in England in 1925, trained as a mechanical and aeronautical engineer, a former Royal Air Force pilot, Lunn had worked at AC Cars, Aston Martin, and Jowett before emigrating to America in '58. He joined AMC in '71 as Director of Engineering for Jeep, which AMC had just acquired from Chrysler. He climbed fast. This was the kind of engineer who would leave the biggest car company in the world for the smallest because the smallest one let him build things. Lunn was not the type to sign off on something based on simulations and lab data. Because AMC lacked the budget for extended durability testing before the Cherokee's late 1983 launch, Lunn did something that no American automaker had done before. He entered 2 prototype Cherokees in the Paris-Dakar Rally, not to win, not even to compete, just to run the brutal 6,200-mile course across the Sahara Desert and see what broke. It was the cheapest, most savage durability test imaginable. Use the most punishing race on earth as your quality control department. That is either brilliant or insane. With AMC, it was usually both. Working alongside Lun was François Castaing, a French engineer who came to AMC through the Renault partnership in 1979. Castaing developed the XJ's drivetrain and brought a rigorous European approach to chassis dynamics and suspension design. He would later become one of the most influential figures in Chrysler's product development. But that comes later. We dig into stories like this every single week. The engineering, the people, the failures, the breakthroughs. If that is your kind of thing, and you are not subscribed yet, now would be a good time. All right. Under the hood, the Cherokee had an engine problem. Several, actually. The base power plant was a 2.5-liter 4-cylinder that AMC had developed in-house over 3 years under Lun's direction. According to Lun himself, the engine was designed specifically for Jeep vehicles, not adapted from a passenger car application. It made about 105 horsepower in carbureted form. A find for highway cruising, nearly useless when you pointed the Cherokee at a hill. The optional 6 was a 2.8-liter V6 purchased from General Motors. It was problematic from the start, underpowered, known for reliability issues, and it came paired with a Ford-sourced carburetor, a GM engine with a Ford carb in a Jeep. The engineering equivalent of 3 rival gangs trying to share a cab. Making things worse, GM could not always supply enough engines to keep AMC's assembly line moving. Production bottlenecks because your competitor cannot be bothered to ship parts on time. That is AMC's entire existence, summarized in one sentence. Then there was the old 258 Inline-Six. This engine had roots going all the way back to the Typhoon 232 that AMC introduced in 1964 as a completely new design. That original engine was genuinely modern for its era. Short stroke, 7 main bearings on the crankshaft, clean architecture. But 20 years of emission control band-aids had strangled it. By the mid-'80s, the 258 was making about 112 horsepower with its computer-controlled carburetor, and the Cherokee's compact engine bay, designed around smaller power plants, couldn't easily accommodate the long 258 without significant modification to the firewall and radiator support. The Cherokee engineers knew what they needed, their own Inline-Six, not borrowed, not wheezing. Something with real fuel injection. Something that could compete with the V8s Ford and Chevy were putting in their trucks. Fewer cylinders, better economy. And it had to happen immediately because AMC was running out of everything. Time, money, corporate patience from Paris. Mostly money. Development started in 1984. The mandate was clear. No clean sheet design. AMC did not have the capital for entirely new tooling, so the engineering team did something that was equal parts clever and desperate. They took the architecture of the 258 and fundamentally reworked it. This was not a rebore. It was re-engineering from the inside out. They used the bore dimension from their own 2.5-liter 4-cylinder engine, which had been intentionally designed in 1981 to share bore spacing and tooling with the 6-cylinder family. Same 3.875-inch bore. New crankshaft with a shorter stroke at 3.414 inches, making the engine over square. New connecting rods at 6.125 inches, similar in length to the long-discontinued 199 engine from 1970. A completely revised combustion chamber design, improved port geometry in the head, better cam profile, and multi-port fuel injection. The sharing strategy was deeper than it looked on the surface. Because the 4-cylinder and the new 6 shared bore dimensions, They could share pistons and rod forgings. Same tooling, same suppliers, same quality control processes. For a company with AMC's razor-thin margins, this kind of parts commonality was not just smart, it was survival. 26 months from start to finish, the entire development program. For reference, the Big Three were spending 4 to 5 years on comparable engine programs with 10 times the budget. AMC completed it in just over 2 years. One AMC engineer later observed that the company did not have enough staff to value engineer all the margin out of parts, which meant there was extra robustness in the design almost by default. They overbuilt components because they literally did not have time to calculate how thin they could make them and still have them survive. This would turn out to be one of the best accidents in automotive engineering history. The fuel injection came from Renix, a contraction of Renault and Bendix, the joint venture established in 1981 in Toulouse, France. Renault held 51%, Bendix held 49%. When Renault hit financial trouble in '85, it sold its stake to Allied Signal for $200 million. The technology became part of Bendix Electronics, but the Renix name stayed on the engine. The system was multi-port fuel injection, an individual injector for each cylinder. In 1987, this was cutting edge for a truck engine. Most competitors were still running carburetors or, at best, throttle body injection, where a single injector sprays fuel into the intake manifold and hopes for even distribution. The Renix system also included a knock sensor that let the ECU retard spark timing if it detected detonation, which meant the engine adjusted itself to fuel quality automatically. You could run regular unleaded without worry. The system worked in Renault sedans in Europe 3 years before it showed up in American Jeeps. One significant flaw: the Renix computer had no permanent diagnostic memory. Turn off the ignition, and any stored trouble codes disappeared. Diagnosing intermittent faults required catching them live or owning one of the very few compatible scan tools. Chrysler's DRB tester worked. Almost nothing else did. This limitation drove mechanics and owners equally crazy for years. Now, the technical details. This is where the engine earns its reputation. 242 cubic inches of displacement. Over-square design, bore larger than stroke. Typically an arrangement that favors higher RPM breathing. But AMC was not chasing horsepower peaks. They wanted torque. The kind of torque that pulls a loaded Jeep up a rocky incline at walking speed without complaint. Low end, immediately available, relentless torque. And they got it. The crankshaft. 7 main bearings. 7. On a 6-cylinder engine, 1 main bearing between every cylinder, plus 1 on each end. Most V8s of the era ran 5 main bearings. Some Inline-Sixes managed with 4. 7 was overkill by any standard, and it was the right call. 7 bearings eliminate crankshaft flex under load. The crank cannot whip or deflect, even under severe and sudden loading. This matters enormously in off-road use, where wheels gain and lose traction violently, shock-loading the drivetrain in ways that would stress a less supported crankshaft. Combined with the Inline-Six layout, which fires at perfectly even 60-degree intervals, the result is an engine that is both supernaturally smooth and structurally overbuilt. No primary vibration, no secondary vibration, no rocking couple. Naturally balanced in every axis without counterbalance shafts or additional hardware, the only layouts that match an Inline-Six for smoothness are a flat 6 or a V12. Neither fits in a Jeep. Cast iron block, cast iron head, forged steel connecting rods, cast aluminum alloy pistons with a friction-reducing skirt design, hydraulic roller lifters in later versions. Nothing exotic in the materials, everything heavy-duty in the execution. The compression ratio sat at 8.8 to 1. Low. Intentionally. Low compression meant regular 87-octane fuel worked fine. It meant less mechanical stress per combustion event. It meant less heat. It meant the engine could run forever at partial load without stressing itself, which is exactly what Jeeps spend most of their time doing. Crawling over obstacles at low RPM with the throttle barely cracked open. That is where low compression and generous torque earn their keep. The valve cover. This one detail tells you everything about AMC's engineering culture. Cast aluminum, secured with 15 bolts on a valve cover, the most of any production engine in the industry at the time. The old 258 had a chronic problem with oil seeping past the valve cover gasket. It was the single most common owner complaint. AMC's solution was not to reformulate the gasket material. It was not to change the sealing surface finish. It was to install so many bolts, torqued so precisely, that oil physically could not find a path to escape. Absurd? Maybe. Effective? Completely. The 4-liter valve cover did not leak. The problem was solved through sheer mechanical determination. Weight. 483 pounds. The old 258 weighed 482. A 1-pound difference despite heavier-duty internals, a more robust crankshaft, additional main bearing support, and a complete multi-port fuel injection system with all its associated hardware. The engineers had made the engine stronger, more complex, and more powerful while adding the weight of a baseball. This is invisible engineering. Nobody writes press releases about it. But it represents a level of design discipline that the Big Three, with their massive budgets and enormous staff, were not consistently achieving. First-year output, 173 horsepower and 220 pound-feet of torque with the Refinements system. By 1988, higher-flow fuel injectors and a compression bump raised numbers to 177 horsepower and 224 pound-feet. Context. In 1990, here is what the competition offered. The Chevrolet 305 V8, 5 liters, 8 cylinders, made between 145 and 170 horsepower depending on tune. Ford's 302 V8 sat in a similar range. The Chrysler 318 made about 170. AMC's own 360 V8 in the Grand Wagoneer, nearly 6 liters with a 4-barrel carburetor, made 144. The GM 4.3 V6 produced 160. Ford's 4.9-liter Inline-Six in the F-150 managed 145. Nissan's 3-liter V6 in the Pathfinder hit 153. The 4-liter beat them all, every single one, with fewer cylinders, with less displacement, with better fuel economy, from a company that, by the time this comparison was meaningful, no longer existed. In a 1990 comparison test published by a major automotive magazine, a 4-door Cherokee with the automatic transmission and 177 horsepower 4-liter hit 60 miles per hour in 10.5 seconds. It beat everything in its class. A 4-wheel drive truck with a live axle running a sub-11-second 0 to 60 in 1990. That was quick. Meanwhile, the company that built it was already gone. November 1986. Georges Besse, a president of Renault and the executive who had championed continued investment in AMC, was assassinated outside his Paris apartment by 2 members of Action Directe, a far-left militant group. They claimed the killing was retaliation for 21,000 layoffs Besse had ordered at Renault. His death removed the single most important advocate for AMC's survival within Renault's leadership. The new Renault president, Raymond Levy, moved to divest. AMC had just posted a $91.3 million annual loss. The writing wasn't just on the wall, it was tattooed there. March 9, 1987. Chrysler agreed to buy Renault's 46% stake plus all remaining shares. The total price ran between $1.5 and $2 billion depending on how costs were allocated. Lee Iacocca, Chrysler's chief executive, did not pretend to care about AMC's car lineup. He wanted Jeep. He wanted the new assembly plant in Bromley, Ontario. He wanted 1,300 dealerships nationwide. He told the press Jeep was the best-known automotive brand name in the world. Everything else, the Gremlins, the Renault Alliance, the Eagle, that was overhead to be dealt with. But Iacocca also acquired things he perhaps did not fully appreciate in the moment. He got the 4-liter engine, he got François Castaing and AMC's engineering team, and he got their product development process, the CAD-based system that AMC had pioneered out of necessity because they couldn't afford the slow, iterative methods of larger companies. Chrysler adopted that system company-wide. Within a decade, they had some of the lowest development costs in the American auto industry. The 4-liter was not the only thing AMC gave Chrysler that kept delivering long after the acquisition closed. Chrysler's engineers refined the 4-liter for 1991. The Renix system was replaced with Chrysler's own multi-port injection, fully OBD1 compliant and capable of permanently storing diagnostic trouble codes. The intake ports were raised about 1/8 of an inch to improve the airflow entry angle. Larger throttle body, redesigned intake and exhaust manifolds, a new camshaft profile that sharpened throttle response. The result was 190 horsepower and 225 pound-feet. Chrysler stamped 4.0-liter high output on the fender badges, and the new cam and computer tuning eliminated the EGR valve and knock sensor, which simplified the engine but made it less tolerant of modification and required some owners to run mid-grade fuel to avoid detonation. In '96, the block was redesigned. Chrysler thinned the walls, removing roughly 70 pounds of cast iron. To compensate, they added a stud girdle across the main bearing caps and additional internal webbing. Less material, same structural integrity, lower production cost. Engineers and accountants both satisfied. That alignment is rare enough to be worth noting. For 20 years, the 4-liter powered nearly every significant Jeep. Cherokee XJ from '87 through 2001, Comanche pickup from '87 through '92, Grand Cherokee ZJ starting in '93, and then the WJ after that. And the Wrangler. But the Wrangler's story deserves its own paragraph. The YJ Wrangler launched in 1987 alongside the 4-liter Cherokee, but it did not get the new engine, not even as an option. The YJ stuck with the old carbureted 258, making 112 horsepower for 4 years, while the Cherokee was running around with 177 horses from a fuel-injected power plant that made V8s look lazy. The Wrangler, the vehicle people bought specifically to go off-road, was stuck with the inferior engine. Why? Because the Renix fuel injection system was only certified for the Cherokee and Comanche platforms. Chrysler did not put the 4-liter in the Wrangler until 1991, and when they did, it came with their own fuel injection system, not Renix. On the YJ got the high-output version right from the start, making 181 horsepower, slightly less than the Cherokee's 190 due to a more restrictive exhaust system. Even slightly detuned, it transformed the Wrangler. The TJ generation continued with the 4-liter all the way through its final year, 2006. It was manufactured in China through a joint venture with Beijing Jeep, where modified Cherokee production continued years after the American line went dark. In 2007, Chrysler retired it. The replacement was a 3.8-liter pushrod V6 pulled from the corporate parts shelf, the same basic engine found in the Dodge Caravan and Chrysler Town and Country. Enthusiasts immediately and permanently nicknamed it the minivan motor. On paper, it made 202 horsepower and 237 pound-feet. Marginal improvements. In practice, the power arrived much higher in the rev range, gutting the low-end authority that had made the 4-liter ideal for off-road work. The 3.8 also earned a reputation for burning oil and spinning main bearings at mileages the 4-liter would have considered warm-up. When the Pentastar 3.6 V6 replaced the 3.8 in 2012 with 285 horsepower, the relief among Wrangler owners was almost audible. The reasons for killing the 4-liter were entirely rational. Last AMC-era engine still in production. Single application power plant used only in the Wrangler, worn tooling at the factory. Expensive to certify for tightening emission standards using 1980s pushrod architecture, and the engine's dimensions, long and tall, created packaging challenges for evolving frontal crash regulations. Economics and regulations won. They always do. The 4-liter's influence outlasted its production run by years. The engine was not perfect. Nothing is. The oil pump had a habit of wearing out around 150,000 miles, requiring proactive replacement by anyone who planned to keep their Jeep long-term. The exhaust manifold was prone to cracking, a problem that plagued the engine across its entire production run and was never fully solved. Oil seepage from the rear main seal and the oil filter adapter gasket was common enough that Jeep forums have entire subsections dedicated to the topic. And in 2000 and 2001, Chrysler introduced a cylinder head casting number 0331 that developed a tendency to crack between the third and fourth cylinders. The crack would weep coolant into the combustion chamber, and if caught late, it was engine over. A revised casting with the word "Toopy" stamped on it eventually fixed the problem, but not before a lot of owners got burned. The engine had flaws. It just had more virtues. The engineering discipline it represented, building for durability over peak numbers, designing for the real world rather than the spec sheet, prioritizing longevity over flashy statistics, that philosophy shaped Jeep's reputation for an entire generation. People who bought Cherokees and Wranglers in the 90s learned to trust the brand because the engine, despite its quirks, fundamentally never quit on them. That trust became brand loyalty that Chrysler and later Stellantis have been drawing down ever since. In the aftermarket, the platform is far from dead. Stroker kits push displacement to 4.6 or 4.7 liters using 258 crankshafts and custom pistons. Turbo builds have exceeded 1,000 horsepower on the dyno, 1,000. From basic architecture that debuted as the Typhoon 232 in a 1964 Rambler, the 7-bearing crankshaft, the forged rods, the iron block, all of it was overbuilt so far beyond original requirements that enthusiasts are still finding performance headroom 6 decades later. Clean Cherokee XJs have become genuinely collectible. Prices have climbed steadily because people realize the combination of a nearly indestructible Inline-Six, simple mechanical systems, and real off-road capability does not exist in new vehicles anymore. The trucks got heavier, the electronics got more complex, the engines got more powerful on paper but less enduring in practice. The 4-liter was the end of a particular kind of engineering honesty. Roy Lund died in August of 2017 at 92. He was called the godfather of the modern SUV for the Cherokee XJ and the godfather of the GT40 for his work at Ford. Not many engineers collect two legacies that significant. The 4-liter was among the last projects he oversaw before retiring from AMC in '85. He left knowing it was good. He probably did not expect it would still be turning over 4 decades later. In vehicles driven by people who weren't born when it was designed. So that is the AMC 4-liter. 15 bolts on a valve cover because they refused to let it leak. 7 main bearings because they refused to let it flex. 1 pound heavier than the engine it replaced because they refused to accept compromise. More powerful than V8s, carrying 2 extra cylinders and a liter more displacement. More durable than anything the American auto industry had produced. Built by engineers at a dying company who decided that the engine, at least, would survive. And when they finally stopped building it after 20 years, they replaced it with a minivan engine. Nobody who loved the 4-liter has ever fully forgiven that decision. And there you have it, the AMC 4-liter straight six. If you have owned one, worked on one, or you are still daily driving one past 300,000 miles, let me know in the comments. I probably missed something. Tell me about it. And if you made it this far, go ahead and subscribe. We do this every week.